Good morning, good morning, good morning. So, I was an actual teacher yesterday, and I wrote out what I needed to get through today. So this is where we're going to start. Okay? All right? So, we want to convert theta equals 60 degrees from a polar equation, which it's in, that is already a polar equation, into a rectangular equation. Okay? So we should first figure out what theta equals 60 degrees looks like, and then that will help us get to where we need to get it to. Okay? So if I were to graph the equation theta equals 60 degrees, what would it look like on a polar graph? Polar graph, what would that one look like? We got
A line through the origin going up.
line through the pole on the polar graph. Yep. Okay. We'll get to that one in a minute. So it's a line through the line through the pole at 60 degrees. Right? Okay. So it looks probably something similar to. Oops. Nope. Gotta do this first. It worked this morning without having to do this, so it's the last one I plugged into. So I don't know why all of a sudden I got to do this. Riveting internets right now. Come on. So it's a line. So 90, 60, like that, right? Line through the pole. Okay? All right. Now, on the rectangular, if I were to put the rectangular coordinate system right on top of the polar coordinate system and match the pole with the origin, okay, we should get the exact same thing. Right? We should get the exact same graph. Okay? So this would be a line through the origin. Oops, I forgot the R in through. With what? What do lines have for that I can find? They've got what, Tess? Slopes. Okay? With a slope, so it's going to have a slope of something. My question is, what is that slope? Well, how do I find the slope of any line? What are some ways? Rise over run. Okay. Subtract the y's over subtract the x's. Okay. For both of those, I need to have 2 points that they go through. Correct? Okay. In your notes, did anybody write down how we find the slope of a line on a polar graph? Should be a tool in our toolkit. Anybody write it down? Okay. All right. Okay. So then we got to go back to another one. We don't have that tool. Okay. So what? So we know that it goes through the point 0, 0, right? What's another point that that line goes through?
Cosine of theta equals x.
Nope. That doesn't get me slope. What's another point that this one goes through?
3/2.
Okay, so there's 2 points that it goes through, correct? So to find the slope, I subtract the y's over subtract the x's, correct? So my slope here is going to be the square root of 3 over 2 minus 0 over 1/2 minus 0. Yes. Okay. So that's the square root of 3 over 2 divided by 1/2, which is what? Square root of 3. So the slope of my line is the square root of 3. Anybody come up with a shortcut? Maybe. Of? So the slope is the tangent of theta. Okay, so the tangent of my angle that I'm going through is the slope. Because the slope at 60 degrees is the square root of 3. Or excuse me, the tangent at 60 degrees is the square root of 3. Okay? So, now I still need to come up with the equation of the line that goes through the origin and has a slope now of the square root of 3. Equation of the line through the origin, slope is the square root of 3. Equation of the line through the origin with the slope of the square root of 3. Let me sideboard it for a second while you're thinking of it. What figure is this right here? Y equals 9x minus 5. What is it? It's a line, right? What can you tell me about that line? (9x minus 5). What can you tell me about the line y equals 9x minus 5? Okay. Y-intercept -5. Okay. So, does everybody understand that? Right? So then we shouldn't have waited this long to find the slope of or the equation of a line that goes through the origin with the slope of the square root of 3. What's the equation of the line through the origin with the slope of the square root of 3? Y equals the square root of 3x. Okay. I would put a set of parentheses around my square root, but that just separates it out for me, visually, kind of, If you don't, be careful, because if you extend your line your radical sign too far, and the x is all of a sudden under the radical sign, then it's a totally different graph. Just so you know. Okay? Good?
I know, I totally thought they were going down.
Yeah, they're going to go down and then whack you across the back. Go pro wrestling on you. Okay? R equals -2 cosecant of theta. Want to convert it into a rectangular equation. What are the R equals tools in my toolbox? Side note, while you're looking those up, I keep forgetting, or I forgot to say in this class, that quiz is on Thursday. Or the test, if you will. The polar test is on Thursday in class. It's a good 2-mod test. Today. What are my R equals tools? r equals the square root of x squared plus y squared. Okay, what's another r equals tool? Or something that's got r in it, I should say. R squared equals x squared plus y squared. Okay. Still we need something with an r and a trig, some trig in it.
X equals R cosine theta.
Okay, and what's the other one?
Y equals R sine theta.
Okay, so those two include r and a trig function, right? Okay, the first two didn't include the trig function. Okay, and notice how we've got a trig function. We've got an r and a trig function in this one. Okay. Do I have either sine or cosine in this one? No, I got cosecant, right? Could I make sine or cosine out of it? Okay, well, what's cosecant? 1 over what? Sine. So negative 2 cosecant is negative 2 over sine. Yes? Yeah? Okay. Can I do anything with that equation? I love them, but not everybody else does. I love the fractions, but not everybody else does. What's your feeling on them? No? Okay, so if you don't like them, should we get rid of it then? Okay, so how are you going to get rid of that fraction? Multiply by sine of theta, both sides? Okay, so if I multiply both sides by sine of theta, I get r sine of theta equals negative 2. Isn't that what you said? What did you say r sine of theta was?
Y.
Y. Yeah. So this is really just y equals negative 2. Now, rectangularly, what is the shape of the graph of y equals negative 2? It's a what? Horizontal line. 2 down from the x-axis, right? Okay. So, looks like that. Yes? Okay. Love it. Can't get enough of it. No, I can't get enough of it. Okay. Polarly wise, if I were to go onto my graphing calculator and I were to insert a polar equation, okay, my polar equation would be negative 2 cosecant of theta I get the exact same thing. Fun. And I can't do both at the same time. So now I need this one. Yeah. Again, riveting internets. So this one up here is and then we get the exact same thing. Okay. Love it. R equals 3 sine of theta. 3 sine of theta. Okay? So tools that we have in our toolbox, we've got r equals square root of x squared plus y squared. We got x equals r cosine theta, y equals r sine theta. We got r squared equals x squared plus y squared. This one we do a little differently because I don't have that r sine theta. And I can't divide both sides by sine and get r sine theta. Okay? So let's introduce an r onto the right side. If I can multiply that by r, right? Is that legal? Or what do I also have to do to make it be legal? And multiply the other side by r also. Okay? So that gives me r squared equals 3r sine of theta. Yes'm? What's r squared? X squared plus y squared. What's r sine of theta? Y? So to make it look nice and pretty, we'll put everything on one side. Now, based upon your knowledge from first semester conic sections, what shape is that box? It's what?
Circle.
Circle. What can you tell me about that circle? Is it going to be centered at the origin?
No.
Okay. Up, down, left, or right? Take a guess.
Down.
Give me another chance.
Up.
Up. It's going to be up. Okay.
Has a radius of 1.
Radius of 1? Sure. It's actually got a radius of 1.5. I think. Factor the 3 out. I think it's 1.5. Alright, let's try. Let's check. Okay. Alright, so graph. So this would be a circle, we said. 1, 0, -3, and 0. Okay. Radius of 1/2. 1.5. Yep. Okay. So there's that one. Now, polarly wise, again, I go into my graph and entry, that one, polar, and I'm going to go 3 sine of theta. Then I get the same thing. So again, this one was the rectangular. And this one was polar. Okay. Awesome sauce. Love it. Okay. So we are now in the purple packet for sure. There should be a page coming up that looks like 6.5 sketching graphs of polar equations. Okay. So these first four are just, we've already done them, kind of a deal. So you don't have to write these first four down. Yep. Okay, we don't have to write these first four down. Okay. So easy graphs without a calculator. R equals 2. What does that polar graph look like? R equals 2. Polar graph. What you got, Emma? Circle with? Radius of 2. Centered at? The pole. Okay, so it's centered at the pole, and it's got a radius of 2. Agree? Okay. R equals negative 3. What's that one look like? Circle with a radius of 3, centered at pole. Yeah, exactly. Okay. It's just instead of, like on R equals 2, I started here, and I went that way around. On R equals negative 3, I would actually start here, but I would still go that way, counterclockwise, around. It just has a different starting point. Okay? No.
Yeah.
Okay. Just so you know. Okay? Good to go there. Love it. Theta equals 120 degrees. What's that one going to look like? Line going through the pole at 120 degrees. So that would be that line. Okay. Theta equaling negative 120 degrees. Not the same thing. What's it going to look like? Line through the pole. So what is another way to say negative 120 degrees? 240? So it's that one. Okay? All right? Love it. Those are the easy ones. R sine of theta equals 2. This is now on that purple page that we're talking about. So this is where we'll pick this one up now. Okay, R sine of theta. What's R sine of theta? Y. So this is really, so I'm thinking here that this is Y equals 2. So it's a horizontal line, 2 radiuses down from the pole, right? Oh, 2, it should be up. I'm sorry, I saw the negative, I was looking ahead.
I'm so wrong on that.
Up from the pole. Wanted to see if you guys are still paying attention or not, Emma. Right? Yeah, whatever. Yes? Good. Love it. Okay. R equals cosine, or excuse me, R equals. R cosine of theta equals negative 3. What's that one? And what shape is x equals negative 3? Vertical line. 3 to the left of the pole. have this one. Okay? So if I were to think about this one. Okay? If I were to think about this one, r equals 4 cosine of theta. R is like y. Or no, excuse me, r is like x, right? Isn't it? And theta is like y in the pole? Or is it flipped around? Which one is it? You know what I mean? What's the in a polar? What's the independent variable that we put in a polar graph? R or theta? 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 Theta. Okay? So that means theta is like x, because that's the independent one. So this is really y equals 4 cosine of x. I know it's weird how we do that, but we think because we set the degree and then we go out. You know what I mean? Yeah. It's backwards thinking. It makes things easier, but it also makes them more complicated at the same time. So if I had you graph y equals 4 cosine of x. Easy? Did he get it right? Yes. You actually did. Yeah.
This is my day.
Okay. So where does the cosine start? Starts up, right? Okay. So it starts up, and then it goes to 0, and then it goes down, and then it back to 0, back up, right? So as our guest just said, it looks like that.
I love it. My brain is
Hey,
working
hey,
today.
hey, he is on points today.
That's true.
Did you need?
I need Isaac for a
Okay. All right.
second. Just for a second. Your stuff there.
Okay. So how high does it go? This one. How high does this one go? 4. So it goes up to 4. Let me put that in. Let me go into red here. So it goes up to 4. How low does it go? -4. Spacing wise, it starts at 0. And then this would be pi over 2, pi, 3 pi over 2, and 2 pi. Correct? Yeah? Okay. Love it. So now, let's fill in my table in the polar graph. Okay? So we're actually going to fill this in. It's kind of a goofy one, because remember, this is y now, and that is x. So we're thinking reversed here. Okay? So at theta is 0, what is my r value? +4. At theta is pi over 2. what is my y value? 0. At theta is pi, what is my r value? -4. At theta is 3 pi over 2. What is my r value? 0. And at 2 pi, what is my r value? 4 again, right? Okay. And 7 pi over 4. So halfway here, where would I be at? Would I be at 2? Okay. So what is the cosine at pi over 4? Be 4 times square root 2 over 2, which would be 2 square root 2. At 3 pi over 4, where would I be? -2 square roots of 2. 5 pi over 4. -2 square roots of 2. 7 pi over 4. 2 square roots of 2 over 2. Actually, no. 2 square roots of 2, not over 2. That would just be the square root of 2. Okay. So let's put that onto our graph now. Okay. So at 0 degrees, I'm 4 radii out. So I'm right there. Now, unfortunately, we got a mismatch here, right? We went radians in our chart, but we got degrees on our polar graph. So this is like 45 degrees, 90 degrees, 135, 180, 225, 270, 315, and 360. Right? Degrees might be a little easier because that helps us with our polar graph. Okay? So at 45 degrees, I'm out 2 square roots of 2 radii. How far is that? 2 square roots of 2. 2.8? 2.828? You guys got calculators. Help me out. 2 square roots of 2. 2.8? Approximately? 2.828? 2.8282? What is it? Man, biscuits and gravy. So 2, 3, so right about, oops, it's why am I green now all of a sudden? So right in there. Yes, okay. 90 degrees, where am I at? I'm at the pole still. 135 degrees, where am I at? -2.28, right? So that means I got to go this way to down there. (180°), I'm at -4. Well, that puts me back at that one. 225° is -2 square roots of 2. So that puts me back there. 270° is 0. So that puts me back there. 315° is 2 square roots of 2, which is 2.8. Puts me right there. And 360° is here again, which puts me at +4. So my graph looks like that. Let's go to the graphing calculators now. And what I would like you to do is, I would like you to start a new document. So double tap the on, new document, not saving anything. Okay? And what I want to do is I want to graph for cosine of theta, and then I also want it to fill in the chart, or show you how to fill in the chart. Okay? So we're going to go to adding a graph, menu, graph entry edit is going to become polar. For cosine of theta is going to be the equation. Theta needs to be in a set of parentheses. Okay? Now, to make it be in degrees like your graph on the paper that you're going to have to do, what we're going to do is we're going to go back into menu, and we're going to go down here to settings. And we're going to change our graphing angle into degree. And then you're going to hit OK. Oops, and then that we should have done that first, I guess, because apparently it just erased it. Now, when I do that, I've got to change this from 6.28 degrees to how much? I got to change that to 360 degrees. Now, what I'd like to show you is how to fill in this chart using the trace function. Okay? So we're going to go menu, trace, but I'm going to set my trace step. I want my trace step to be 45 degrees. Okay? I could make it be 15 degrees, and then I would be hitting every single of the lines on my polar graph paper. Okay? Or I could make it 30 and go every other. Okay? Or I could make it 45 and go quarters all the way around. Okay? So we're going to hit OK on that, and then, whoops, trace step too large. Why is my trace step 45 not too large now? We'll go 15 then. Be that way. we can't go 45. We'll go 15. We'll just have to double tap, or triple tap actually, to get it to the 45s. Okay? Then, go back into trace. And if I swing it around, now I'm at 0. So I'm at the point 4, 0 degrees, which is the first line that we have in there. And then if I go to the right, 3. Okay. So now I'm at 2.83, 45 degrees, which is 2 square roots of 2, 45 degrees. Go 2 more, or 3 more. I'm at 0, 90, which is the third line in our chart, in our T-chart. One more. Negative 2 square roots of 2, 135 degrees. Negative 4, 180 degrees, and so on and so forth. We can keep going around, and that would fill in all the values on our chart. All the way back to 360. Okay? So, let's do another one. I think this is on the back side. Top one on the back side. 1 minus 3 cosine of theta. So let's first graph it on our graphing calculators. And then we will trace it onto our other one. It's a great polar graph. Okay. So put a little curly Q. I wore this bracelet for a reason. Okay. So put a little curly Q into the circle. Okay. So now we need to transfer that onto our graph. Okay? So we're going to trace it. So the first point is going to be at negative 2, 0. Okay, so 0 degrees, we're going to go negative 2. This is one of those where I need I need 2 screens going on here now. Okay? So negative 2, 1, 2, right there. Then, you guys want to go by 15s or 30s? What do you want to go by? 45s? How many degrees do you want to go by? 15s? Okay. We'll put, because I don't think we have enough spots in our T-chart. So we can go by 15s on the graph, but on our T-chart, we probably should go by 45s. Okay? So at 45 degrees, I'm at negative 1.2. this is me, this is a personal thing for me. As I fill one in, I continue my line, or I connect the dots, if you will. I don't wait until the end to connect the dots. Okay? Next one. I'm at 1, 90 degrees. Next one. 3.12, 135. Next one. 4, 180. That's going to bug me. Now it's not going to bug me anymore. Next one. 225 degrees, 3.12 again. One, 270. -315, -1.12. I didn't skip over there. And then this one should be at -2, 360 degrees. Because the top and the bottom row should be the same. Because they're the same angle. Okay? And that's the polar graph. What I'd like you to do now is I would like you to graph me 3 sine of 2 theta. So it should have looked like 3 sine of 2 theta. So it should look like that. Where it goes out, if I trace this, goes out 3 on the 45s. Okay? So it goes out 3 on the 45s, would mean I would go out 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, and 3. And then I would make my petals
Like that.
okay. You can get all that in, all the chart stuff from, should be, if you went 45s on your chart, it should be 3s and 0s and negative 3s. Which I think it should just, yeah. There's some negative 3s in there too. Okay.